Hey everyone, this is Dr. Walker. This is the guided examples from video 245, I know it's hidden back there, the time constant of a RC circuit. So let's look at this example that has three parts. It's called charging capacitor. We have an uncharged capacitor, a resistor, and they're connected to a battery. So I went ahead and drew this out, the voltage, the resistance, the capacitance. Now it says it's uncharged, so really what I should have done is show that there's going to be some kind of switch. It's initially going to be open because it's uncharged, and once you close the switch, then the capacitor will charge. So the first question is, what is the time constant? So that's just a plug and chug definition. Time constant is equal to R times C. So we're going to plug in the resistance of 100 ohms times the capacitance of 23 microfarads, and multiply that together is going to give us 0.0023, and the units for time constant is seconds. Remember, it's just a specific amount of time. Let's take a look at part B. What is the maximum charge on the capacitor? So this is another plug and chug into our equation for maximum charge, which was given to us as the capacitance times the EMF. So we're going to multiply the 23 microfarads times the 7 volts. And that's going to give us 161 microfarads. So what this means is once the switch has been closed and the capacitor has had plenty of time to charge, that will be the maximum charge that can accumulate on that capacitor. Let's look at the last part here. What is the charge on the capacitor after one time constant? So it's going to be less than this because this is the maximum charge. After one time constant, we don't reach the full charge quite yet. So let's use our equation for the charge on a capacitor as it's charging. And the equation looks like this. The charge as a function of time is equal to the maximum charge times 1 minus e to the negative time over tau. So that's our equation for charging capacitor. Again, how do we know that it's charging? Because it was uncharged and it's connected to a battery. When a capacitor is connected to a battery, it's going to be charging. So to find the charge after one time constant, that's what our time is going to equal to. This means time is going to equal tau. We want to find the charge after that amount of time has passed. So Q after tau has passed is our Q max times 1 minus e to the negative tau over tau. So that equals Q max times 1 minus e, and then negative tau over tau cancels out, negative 1. Okay, so what we're going to do is we're going to plug in all of this into our calculator. We've already plugged in e to negative 1 and gotten 0.37. So if you do 1 minus that, you're going to get Q max times 0.632. So this is significant. After one time constant, when you're charging a capacitor, you get up to 63.2% of your maximum charge. While for the discharging capacitor, after one time constant, you went down to 37% of your maximum charge. So you don't have to memorize these numbers, but you have to be able to understand that they just come from the exponential function. So if we multiply 161 microfarads times 0.632, that's going to give us 101.8 microcoulombs. And sorry, I put farads here. Mistake. Charge is measured in coulombs, not farads. All right. So that is it for this example. I do want to make a note to really pay attention to the equations that you're using. We have a summary slide here that shows all of the equations, and I'm gonna put me up here, make sure I'm not in the way here. You see that the equations for the current are the same, but they're different for charge and voltage. So if you have a circuit where you have a battery and a resistor and a capacitor, then you're going to be charging that capacitor and going to be using these equations if it asks about charge and voltage. If you have a circuit where you just have that resistor and that capacitor, then you know that the capacitor is going to discharge through that resistor, and then you use the following equations. Hope that was helpful, and I will see you next time.